Coding.
Hi guys.
Hello. Okay. Let's get it started. So today we're gonna talk about black box testing, and I think we're all familiar with black box testing, but there are like different methods which will help us to do this black box testing, and we will talk about them. But first, let's start with what is the black box testing itself. So black box testing is a software testing method in which the functionalities of software applications are tested without having knowledge of internal code structure, implementation details, and internal paths. Black box testing mainly focused on input and output of software applications, and it's entirely based on software requirements and specifications. It's also known as behavioral testing. So we don't know the code, but we know only input and output of our application, and we're performing based on this input and output, how the application will behave, this kind of testing. And there are some types of black box testing, and there are like functional testing, non-functional testing, regression testing. So functional, this is a black box testing type, is related to the functional requirements of a system. It's done by software testers. So we're checking the functionality. Give me a second, I need to admit more people. Okay. So this is about functional testing. We are testing functionality of our, and non-functional testing, this is type of black box testing, is not related to testing or of specific functionality. But non-functional testing requirements such as performance, scalability, usability. So we're testing not the application, we're testing like application characteristics as performance, as usability and stuff. So it's a non-functional testing. And regression testing is done after code fix, upgrades, or any other system maintenance to check the new code has not affected the existing code. So every time after deployment, we need to run our regression test to make sure everything works as it worked before, plus new functionalities added. Okay, this is about regression testing. Okay, there are multiple ways, multiple techniques what we're gonna do, what we're gonna tell, how like some techniques to make our life easier, to find more bugs and make sure we are good QA engineers. So there are like 7 basic, like main testing techniques we need to know. It's a boundary value analysis, equivalence partitioning, decision table testing, state transition testing, error guessing, graph-based testing methods, and comparison testing. We're gonna talk about all of them right now, and we'll go through and figure out what that means. So boundary value analysis. Boundary value and testing is focused on the values at boundaries. This technique determines whether a certain range of values are acceptable by the system or not. It is very useful in reducing the number of test cases. It is most suitable for systems where an input is within certain ranges. So, for example, we're testing some program which takes inputs from 1 to 10, for example. So most of the mistakes and bugs can be found on these boundaries, around this 1 and around this 10. So we're gonna test in our test cases like 0, 1, and 2, and 9, 10, and 11, because most of the mistakes can be found here on these boundaries. We're not gonna test, like, we're not gonna run tests for 3, 4, 5, 6, 7, 8. We can just test like boundaries and assume the program works correctly. This is the boundary value analysis. So we're thinking about boundaries where bugs can be found. Equivalence partitioning is also known as equivalence class partitioning, is the method the input domain data is divided into different equivalence data classes, which are generally termed as valid and invalid. The inputs to the software of systems are divided into groups that are expected to exhibit similar behavior. This reduces the number of test cases to a final list of testable test cases covering maximum possibilities. Yeah, a lot of fancy words, but let's take a look on an example. So basically, when we're testing something, we want to divide our input to two groups, invalid set and valid set. And we're gonna perform like, so we're expecting some positive scenarios and negative scenarios. So for example, if we're having like application which takes age and accepts value only from 18 to 56, we're gonna have our valid set of values like from 18 to 56, and everything else will be invalid. So this will make our life easier if we're gonna divide for different parts our input to perform this kind of testing. Let's go to the decision table testing. So decision table testing is a software testing technique used to test system behavior for different input combinations. This is a systematic approach where the different input combinations and their corresponding system behavior output are captured in a tabular form. That is why it is also called a cause-effect table, where cause and effects are captured for better test coverage. Let's learn it with example. So, for example, we're working, like, I don't know where to apply this example. This looks like some very old government site when we need to download some picture. And it takes only JPG format image, and file size should be less than 32 kilobytes, and resolution will have this like this. So it's really hard to come up with different test cases without this step. So we're doing this table, and we basically thinking about, okay, I'm gonna try with JPEG format, with not JPEG format, with different size, with different resolution, and this is the output I'm gonna have. So you creating this table to better understand, to better cover all the scenarios. Is it clear, guys? Does it make sense? Yep.
Yep.
Okay. So yeah, you're creating to better understand, to cover all possible scenarios and see and report about the bugs you found in this way. Okay, let's go to the state transition testing. State transition testing, it's a black box testing technique in which changes made in input conditions cause state changes or output changes in the application under test. State transition testing helps to analyze behavior of application for different input conditions. Testers can provide positive and negative input test values and report system behavior. So we're gonna, for example, we have like bank application, and we testing PIN code, right, for your card. And we're gonna pass, like, for example, you pretty sure your PIN code is like 4 zeros, and you're trying it first time, you think you mistyped it, you type in second time, third time, and finally account got blocked. So you had like same input, you got different scenarios. Then like first time was fine, second time was fine. After third one, account got blocked. And if you're gonna try like correct pin, it's gonna be working from first attempt, from second, or from third. So that means we will understand better behavior of our program. Sometimes it's like not that easy. Sometimes our program can be like very complicated, and sometimes this flow of our program will be act very differently according to the data we provided. So it's good to know about the states of the program. So it is a model on which the system and tests are based, and a system where you get a different output for the same input depending on what has happened before, and it's a finite state system. So as I mentioned, different or same output will have different scenarios. We need to think about this. So yeah, it's very helpful when you need to test different system transitions. Fifth technique is error guessing. This is what we're usually doing right now because we didn't know about like boundary value analysis or like partitioning. And right now, with so it's also one of the techniques, error guessing. The test cases for finding issues in the software are written based on the prior testing experience with similar applications. So the scope of the test cases would generally depend upon the kind of testing test case was involved in the past. The error guessing technique doesn't allow any specific rules. So you're doing according your experience, you found some bugs in a similar application in some of the places, so you're trying to find and test in the same scenarios. So for example, if the analysis guesses that the login page is error prone, then the testers will write detailed test cases concentrating on the login page. Testers can think of a variety of combinations of data to test the login page. To design test cases based on the error guessing technique, the analyst can use past experience to identify the conditions. This technique can be used at any level of testing. And for testing the common mistakes, like, the most common mistakes can be from dividing by zero, entering blank spaces in the text fields, pressing the submit button without entering values, uploading files exceeding maximum limits, no pointer exception, invalid parameters, etc. But this is like the most common mistakes you can find. The achievement rate of the technique doesn't mainly depends upon the ability of testers. So yeah, every tester will have own rate and own logic and own experience how to find these mistakes. Graph-based testing methods. Graph is one of the most widely used structures for this supposition. It is a well-defined structure which makes the testing of or case studies easier. It is considered as an effective way to determine the systematic test selection of a system. This model is used to present the desired information to be captured and collected. Next, the information to be shared is also presented and easily understood by testers. So we basically drawing graphs of our application and its behavior with different scenarios to better understanding the flow and easy test some of the functionalities. For graph-based testing, firstly, the tester is asked to collect the data from graph model and then cover all the elements for a particular graph. In this process of testing, the tester is first assigned by the responsibility of creating a graph followed by other steps. These are discussed next. So steps for graph-based testing includes build the graph model. So we basically building whole the model. We will have special like programs and tools to build it. Identify the test measure requirements. Yeah, we need to go and double check all requirements and understand in and out our application. Identify, select the path to cover those requirements, like different like outputs, inputs, and select data to be entered. So the graph helps in certain circumstances to determine the present problem so that decision can be taken fast, to correlate the factors affecting the system, to recognize the main cause of problem. Okay, so advantages of using cause effect graph are as follows. It is highlights the area from which the data is taken and can be taken for additional studies. So we're gonna highlight the areas where and study them better and understand where can be mistakes and stuff. It helps to motivating the team. All these graphs and stuffs can be useful for the team. And excuse me. Okay. The data is arranged in such manner that even a not technical person can also read it. So yeah, it's very clear on graphs, even like PO or BA can easily understand the flow of program and what testing we perform. It helps to detecting the reason or difference secured in the process. It helps the team decide the root reason of a problem. It's very appropriate for large systems. So larger systems, more complicated flow. When we're drawing the graphs, it's easier to understand how it works. And disadvantages of using cause effect graphs are difficult to design, of course, takes a lot of time. It's difficult to choose the important input in limited time. There can be changes where path of drawing the graphs is not clear, and there are chances of repetition of data already entered in the graph. And comparison testing. Comparison testing is all about assessing the strengths and weaknesses of a software product with respect to other software products existing in the market. The goal of comparison testing is to provide pivotal and crucial information to the business to unravel the software product's competitive advantage in the market vis-a-vis loopholes. In general, when a systematic process is followed, test project applications, then quality is maintained, and it's useful in the long run for further rounds of testing. So let's take an example. For example, you working on eBay and you checking like listings, like listing page, and you want to compare with Amazon, for example, and you're going to Amazon website and checking how it's done in their website, comparing like how it's done in your website, and trying to understand like, is it what we expected, check the requirements, and maybe change requirements and talk to your PO about like, hey, the Amazon did it like in this way, it's really cool. Maybe you should do it in the same way and that stuff. So we're comparing with other products already on the market. So using the above mentioned backblock techniques, such as boundary analysis, equivalence partitioning, etc., sets of valid and invalid inputs are identified with their desired outputs, and test cases are designed based on that. The design test cases are executed to check if they pass or fail by verifying the actual result with expected results. The failed test cases are raised as defect, bugs, and addressed to the development team to get it fixed. User based on the defects being fixed, the tester retests and defects verified current. Okay, so conclusion, guys. I know that was a lot, and yeah, all of these techniques will help, and you can take a look and study them by your own, do your research. So these are some of the basic points regarding black box techniques and overview of its technical techniques and methods. Is it not possible to test everything with human involvement with 100% accuracy? If the above mentioned techniques and methods are used effectively, it will definitely improve the quality of the system. To conclude, this is a very helpful method to verify the functionality of the system and identify most of the defects. Hope you will have gained in-depth knowledge of black box testing techniques, guys. And remember, black box matter. Okay, let's jump to Kahoot game to sum up a little bit.
Timur, I have a question.
Yep.
Can you please show your second list, like second slide?
Here? Or this one?
I think next. Yes, this right here. So the black box testing, it include these tests inside, right? Or it's different?
Types of black box testing. So with some of the tests can be like functional, with testing like functionality, like input and output, and some tests can be non-functional with testing performance, scalability, usability. So why black box? Because we don't see the code. We don't know code. We don't know how it works, how it implemented, but we can only test usability, scalability, performance. It's non-functional. And functionally, we can test on the input and output and some behavior of our program.
And one more question about the methods and techniques which you show. Yeah, these ones. Are we responsible for all this, or we just have to know about this?
Good to know. You know, you're not responsible. I don't think someone will like hardly ask you like according to these techniques on an interview, but it's good to know about this, and it will help you in real job. It will help you. You're not gonna like you know, create test cases for 5, 6, and 7, and you will create for 1, 0, 1, 2, and 9, 10, 11, and find more mistakes and bugs here, whereas here or here or here. So just like, I think all of these techniques are like, you can understand them without knowing the names of it. Like it's just you right now you're using them, but you not know it's a boundary value analysis, right? You're performing some tests and you're thinking, okay, probably I need to test this and this, but you're like
it's kind of definition, right?
Yeah, this is kind of like you know, like more scientific way to tell about tests. And yeah, it's been developed like for last 20 years. People, I don't know, like did dissertations and stuff about tests and different. They need to come up with different like fancy words and fancy ways to talk about tests, because it's still engineering. We're still gonna be test engineers. We need to show off a little bit.
Yep. Thank you.
Can you show first slide again, please?
This one?
First one, definition.
Mm-hmm.
I don't have a questions. I just.
Oh yeah, sure.
Wanted to get. Okay, thank you.
Yes, the keywords here, without having knowledge of internal code structure, implementation tells an internal path.
Thank you.
You guys ready for Kahoot game?
Yeah.
we're gonna sum up it a little bit to clearly understand all this. Okay, where is my Kahoot game? It's probably fold it. Okay, so let's go to Kahoot game. Can you guys see it?
Yeah.
Yes.
Yeah.
Okay. All boxes matter, love it. Every time it's harder and harder to guess who is who. Okay, I'll wait 1 more minute, guys, and we will start. Okay, let's go. Okay, guys, good job. Most of you got it. Okay, eyeball testing. It's an easy one, right? Okay, good job. Good job, Sophie. Good job. Pretty easy, right? Okay, true or false? Yeah, guys, functional testing, it's not includes the usability and performance. It's a non-functional testing. Clear? Or we need to talk about it?
Can you explain a little bit?
Yeah, we talk about like different types of black box testing, and we talk about functional testing and non-functional testing. And functional testing, we testing our input, output, and behavior. And non-functional testing, we testing like performance, usability, of our application. So it's not functional, non-functional testing.
Got it.
Okay. Next question. Yeah, most of you got it. Good job. Yeah, we're basically in equivalence partitioning. We're dividing our input on a valid and invalid. Yeah, you got it. Decision table testing used for. Yeah, most of you got it. Yeah, it helps us to increase our test coverage to see all different scenarios.
Who chooses show-offs?
I should make it also as one knows the right answers. But yeah, we're trying to be serious. I would love to make fun, but I have to teach you something, right? Not only entertain. Okay, state transition testing. Yep. So we can have like same inputs, but with our main function, like our main goal when we're doing state transition testing, is to check different states, check different transitions. Good job, gray box. True or false? Yep, easy one. Yeah, we talk about it, about eBay and Amazon, so we can test and check what we have on the market and check if our product behaves in the same way. Double points for this one. What is the less common mistake? Yeah, it was tricky one, and yeah, this three was in slides about when I talked about common mistakes. There wasn't infinite loops, because infinite loops, it's like not that common mistake because it's easier to find and fix before production, before environment. Okay, white box. I have so many competitive fight here. One more question, guys, and it's also double, I believe. Yep. What is not part of black box testing? I didn't mention it, but try to guess. Last question should be hard, right?
Timur, you gave us so much time, so we can Google it.
Don't cheat. So yeah, smoke testing, sanity testing, and integration testing can be part of black box testing, but yeah, none of them is a correct answer. And yeah, good job. Most of you got it. And let's see who win. Who have won? Gray box. Third, lion face. Second, and first is white box. Congratulations, white box. You win Kahoot game about black box. Okay, guys. Thank you so much for attending.
Thank you, Timur.
Yeah, let's go and
Timur, can you
prepare.
please send
Yeah.
your what's the name?
Social security? No.
Credit card number.
Presentation.
Yeah, sure. Presentation I can
Thank
show.
you.
Yeah.
Thank you, Timur.
Yeah, guys.
Thank
Thank
you.
you.
Thank you.
Bye. Thank you.
Okay.
Thanks.
Have a nice productive day. Bye.